Have you ever wondered if we're not just exploring the universe, but actually living inside one of its most mysterious phenomena? Imagine this: the James Webb Space Telescope, the most advanced tool we've ever created to gaze into the cosmos, reveals that we might be residing within a black hole. A discovery like that would shatter everything we thought we knew about reality itself. Black holes have always intrigued us, haven't they? They're often portrayed as cosmic monsters, swallowing everything in their path. But the reality is even more fascinating, and terrifying. A black hole isn't just an empty void, it's a region where matter is packed so tightly that its gravity becomes inescapable. Imagine something 10 times more massive than our sun squeezed into the size of a city like New York. The pull of gravity would be so intense, not even light could escape. Unveiling the mystery. But how do we know these mysterious entities exist? Since black holes don't emit light, we can't just see them. Instead, scientists rely on the dance of nearby matter to infer their presence, like watching the swirling water around an invisible drain. If a black hole passes through a cloud of gas, it pulls it in, a process called accretion. If a star wanders too close, the black hole tears it apart, producing bright X-rays that we can detect from Earth. The birth of a black hole. Most black holes form when massive stars reach the end of their life cycle in spectacular explosions known as supernovae. When a star can no longer support its own weight, its core collapses under immense gravity. If that core is massive enough, it turns into a black hole. The smaller stars? They become neutron stars, ultra-dense objects, but not quite dense enough to trap light. Here's where things get really mind-bending. As a black hole forms, time behaves in strange ways near its surface. If you were watching from a safe distance, you'd notice that time appears to slow down as it gets closer to the black hole's event horizon, the point of no return. This isn't just sci-fi. It's a prediction of Einstein's theory of relativity. Enter the James Webb Space Telescope. Now, with the James Webb Space Telescope, or JWST, as it's known, we're seeing the universe in ways we've never seen before. Launched over 1 million miles from Earth, it's unfolding the deepest mysteries of space. Think of it as a time machine, capturing light from billions of years ago, allowing us to peek at the universe's infancy. One of JWST's most groundbreaking abilities. It can look beyond stars and galaxies to hunt for exoplanets, distant worlds that might harbor life. Its powerful sensors analyze the atmospheres of these planets, searching for clues like water vapor, carbon dioxide, and organic molecules. Imagine discovering a planet where life exists, hidden in the far reaches of space. Black hole mysteries unraveling. JWST isn't just about finding exoplanets, it's uncovering secrets about black holes too. In fact, it recently helped detect what could be the oldest black hole ever found, formed just 570 million years after the Big Bang. This ancient cosmic giant is about 10 million times the mass of our Sun, and its existence raises profound questions. How did black holes like this form so early? How many more are hiding in the universe's dark corners, waiting to be found? One of JWST's discoveries involved something called polycyclic aromatic hydrocarbons, PAHs for short. These carbon-based molecules help scientists track star formation, but near black holes, things get weird. The radiation from a black hole can transform these molecules, making it harder to use them as markers. It's a puzzle that JWST is helping us solve, and with every answer, we uncover more questions. Are we living inside a black hole? As JWST continues its mission, it might just reveal something truly mind-blowing. Could we be living inside a black hole? At first glance, the idea sounds straight out of science fiction, but what if this seemingly wild hypothesis actually holds a grain of truth? Let's break it down. Black holes are known for their powerful gravitational pull, so intense that not even light can escape. But black holes don't just distort space, they also warp time itself. Near the event horizon, time appears to slow down, an effect that would be imperceptible to anyone within that region. If you were falling into a black hole, from your perspective, time would pass normally, but to an outside observer, your fall would appear to slow, almost freeze, as you approached the event horizon. Now, let's consider the bigger picture. Some physicists propose that the universe itself could be a kind of hologram projected from the surface of a black hole. This is based on the theory of holographic principles, where the three-dimensional universe we experience may be encoded on a distant two-dimensional boundary. If this is true, it implies that what we perceive as the vast cosmos might just be the inner workings of a black hole's complex geometry. Imagine for a second that every galaxy, every star, every planet, including Earth, exists inside this vast, unfathomable region of warped spacetime. If the universe were contained within a black hole, its boundaries wouldn't be physical walls but rather the edges of the event horizon, a place where time, space, and matter are stretched to their limits. But how could JWST help confirm this? The James Webb Space Telescope's ability to peer back in time and observe galaxies as they formed billions of years ago gives us clues about the nature of our universe. Its advanced sensors are detecting subtle distortions in light, in the fabric of space itself. If we are indeed inside a black hole, the telescope might observe unusual signatures that challenge the standard model of cosmology. For example, JWST might detect anomalies in the cosmic microwave background, the faint glow left from the Big Bang, that hint at the universe's curvature being far different from what we expect. The behavior of galaxies, their accelerating expansion, and the presence of mysterious dark matter and dark energy could all be explained if the universe itself were subject to the intense gravitational forces at play inside a black hole. Dark energy, for instance, might not be an unknown force at all, but rather a side effect of spacetime being stretched by the singularity at the heart of the black hole. Furthermore, quantum theory presents another tantalizing possibility. There's a growing theory that black holes don't destroy information as previously thought, but store it in a compressed form on their event horizons. If the universe is inside a black hole, could it mean that every particle, every thought, and every moment of time is encoded in the fabric of space itself? And what about the singularity, the point at the center of a black hole where gravity is infinite, and the laws of physics break down? If we're inside a black hole, then the universe could have originated from a similar singularity. This could mean that the Big Bang wasn't just the birth of the universe as we know it, but rather the expansion of space and time from the collapse of a star into a black hole in another universe, a universe beyond our comprehension. Imagine the implications if JWST's observations suggest evidence for this black hole universe theory. It would rewrite everything we know about cosmology, shifting the narrative from the idea of an ever-expanding universe with an unknown beginning and end, to a cyclical universe, one born from the collapse of a previous reality. The universe might not be infinite, it could have definite boundaries, albeit ones that we can never cross. And if this is true, what lies outside? Is our universe just one of many, each contained within its own black hole, endlessly spawning new realities? Could black holes in our universe give birth to new universes of their own? As JWST continues its mission, we may soon find out if we've been wrong about the universe's fundamental nature all along. The answers could be more profound, more awe-inspiring, and far stranger than we ever imagined. A new frontier of discovery. The JWST is just beginning its journey, and with each new discovery, we inch closer to unraveling the universe's deepest mysteries. From tracing the evolution of galaxies to peering into the birth of stars, and even searching for life beyond Earth, the potential is limitless. Could we one day learn that the universe itself is far more complex than we ever imagined? Maybe the answers lie not in what we see, but in the unseen forces shaping everything. With the James Webb Space Telescope leading the charge, the future of cosmic exploration is brighter, and stranger, than we ever dared to dream.